This is the Precalculus Fall 2016 ACP preview, problem 15. This is a Newton's law of cooling problem. Newton's law of cooling laws temperature T over time T in minutes using the function T sub T, which is the final temperature, equals T sub M, which is the temperature of the medium, plus quantity T sub 0, which is the initial temperature, minus the temperature of the medium, times e to the power of negative KT. And K is a constant of cooling. And this K is, usually this problem is more complicated than they make it here, in that you're going to be given maybe a beginning temperature and then maybe it was 400 degrees, and it cools down to 200 degrees after 20 minutes. Well, how long is the thing going to take to cool down to 100 degrees? Well, you have to find a constant cooling. Here you're given everything, and you just have to fill it in and solve the equation. So you have T sub T, which is your final amount, which is 48 degrees, your final temperature, equals your temperature for medium, T sub N, which is 20, plus you have quantity T sub 0, and you're trying to find the initial temperature of the cookie coming out of the oven. So you put T sub 0 minus T sub M, which is 20, and then you have E, Euler's number, to the power of negative K, and K is given as 0.35 times T, and T is given as 5 minutes. And so you have an equation that you can enter. Now we can solve for T. If we subtract 20, divide by E to the negative KT, and then you have to add 20, you'll have T sub 0. So you can solve it. I'm going to go ahead and use numerical solve the calculator like we did for problem 14. To do that, we're going to go to Menu, Algebra, Numerical Solve, put the equation in here, 48 degrees, our final temperature, equals the temperature of the medium, 20, plus, parentheses, T sub 0, which we don't know, I'm going to call it X, minus the temperature of the medium, times E, and I press the E key, to the power of negative, well, we have our K is 0.35, and we have times 5 minutes. And then we come to the right here and press comma X, and we should get our value right here. So we get 181.13 degrees. So we go to our answer choices, hope that's one of them. Well, here we have it, about 181 degrees. So 181.13 degrees centigrade. So that's going to be our correct answer. Again, it's made easier because you're not having to scramble to find what K is first. Eventually you'd have to do that twice, find what K is, and then apply it to find the final temperature. I'd like you to consider working out problems 15A, a similar problem, and 15B as well, to better cement your understanding, I would hope. Good luck, and thanks for viewing.